All right, you guys, we're going to begin our part 3 discussion of safety rules and things. We're going to start with compressed air and some air tool items. First, here's an air nozzle, okay, for compressed air. This is for blowing chips and things off of parts. It's not for blowing off our bodies. A lot of people do that, and I know that. The danger of that is even if I've got safety glasses on, I can blow stuff up underneath my glasses and into my eyes. If this gets near your eyes at 120 psi, it's enough to blow an eyeball out of the socket. I hate to be gross, but I do always want to tell the story that I heard that one kid, not here at San Luis High, but somewhere in the country, took a compressed air nozzle and put it into no man's land in a kid's rear and blew out his intestines and killed him. And I'm saying that not to be gross, but so that you will understand that something like this could be very dangerous. Another safety item, the reels here, when you pull them down, we talked about the other safety rules about tripping hazards. Pull it all the way down. I'm just re-emphasizing and showing you now, so it's laying on the ground. So if I turn the camera down, you can see it. So it's laying on the ground, and not so it's like this, where somebody's going to get a trip on it. But get it laying on the ground. Try and get it laying out of the way. Another thing is, if I tilt the camera back up, when you release this, the spring on this is really strong. If I let it go, this thing's just going to whap and hit things. So please kind of keep your hand on it and slowly put it away. Next, a little more on air tools. Here's several air guns. Whenever we use an air gun like this 1/2-inch drive impact gun, put the camera down a little bit. Whenever we use an air tool like this, we want to lubricate it with some air tool oil. And what we do is we come and take this and we put a couple of drops, 2 or 3 drops, right where the air goes. And what that does is it goes inside the actual air tool and lubricates the internal components so the gun lasts. If you've got a nail gun at home, whether it's a finished nail or a framing nail gun, how many nail guns do I have at home? I've got 4 nail guns at home. I have a framing nail gun, I have 2 finished nail guns, one's for longer nails, one's for shorter nails, and I have a coil nailer for doing roofing. And for all of those guns, you've got to put air tool oil in. A lot of people don't realize that, or the device is going to fail prematurely, and you don't want to do that. When we use an impact gun, we have to use what's called impact sockets. So these black sockets over here, standard SAE here and metric over here, and also we have these metric, you can see the metric swivel. So those black industrial sockets, if I grab a 14 millimeter deep and I grab a 14 millimeter deep chrome socket, you can see the difference in the 2 sockets. The black one here is much, much thicker in terms of wall thickness. So this one can handle the beating of the impact gun going bah, 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 bah. This one can't. These will break apart and parts will fly. I've seen that happen. It's never a good sight because those metal shards can hit you in the face, etc. So for all those reasons, we're obviously always wearing safety glasses in the shop. So that's what I wanted to talk to you about, compressed air. We've got compressed air running all over the shop. You can see that there's a compressed air nozzle reel down there outside of bay 2. There's one way down there on the wall in bay 1. There's one over there on the wall, on the pillar between bay 1 and 2, between bay 2 and 3, and way over here between bay 3 and 4, and then behind me on the wall, right in between bay 3 and 4 again. So there's 1, 2, 3, 4, 5, 6 hose reels in here, so there's plenty of access to hose. And then 2 other things. At those pillars there, right behind the controls for the rack, there's 2 fittings, so you can also plug in 2 air hoses there. So there's air everywhere to operate tools or to get air for an air chuck to go ahead and air up tires. And here's our air chuck there, and our handle there. Okay, so that's compressed air. So next, I'd like to roll over to this Toyota Tundra and just talk about running an engine and just some safety whenever it's time to run an engine. So hopefully some of these will be common sense, but we've got our belts here and there's a fan right here. And So what we want to make sure is that when we start this engine, no tools are down in here, no hands are down in here, no long hair, no loose clothing. We're not going to stand here when we start the engine. Because if something were in there got thrown out in line with the belt, it's going to throw out in this plane here and across the other side. So you never want to stand in line with the fan. And so when we start the engine, we're up here or we're over here like this. Okay. But when we're starting a car like this one, we don't want to stand in front either, because if it goes into gear, I could get squashed between the cabinets. We don't want to stand behind the car. We don't want to stand in line with the fan. Where do we stand? Over here, or same thing on this side. Over here and over there. Okay. So we're out of the way of the vehicle, and we're out of the way of the belts and pulleys. We also, when we start a car to do any testing, let's put some wheel blocks in front of and behind one of the rear wheels. Could be a front wheel, but preferably a rear wheel, especially in a rear-wheel drive car. We're going to put some wheel blocks, and those are the yellow wheel blocks right underneath the stairs outside the office. That's just in case if the vehicle drops into drive or reverse, it's not going to move and hopefully hurt anybody. Okay, we got to think about where the hot exhaust is. So on this vehicle, the hot exhaust, let me grab my camera here. The hot exhaust that we want to be careful of is this pipe down here. Okay, so it's that pipe down there, like that. This is the valve cover, but the hot exhaust is down there. On this car, it's not easy to touch the exhaust. You can see it running down there. So this one's pretty easy, but you got a transverse mounted vehicle like this Highlander here. If I can get my camera over here, I think it'll come all the way over. Okay, so now you can see the hot exhaust. This is the exhaust manifold. It's got a shield, and it shows a hand with an X. That you're not supposed to touch that. That'll get 600 or 800 degrees very quickly when an engine's running. So we want to be careful about what we're touching. So our general safety rules about working the shop with no long hair or loose clothing or dangling jewelry, anything that can get grabbed. I've seen students working on a running engine have a necklace and it's hanging down, or the hair hangs down right. I've some engines right next to the alternator, and boy, if your hair gets sucked in, it's going to rip your hair right out, and that would be a really, really dangerous thing. Just a couple other thoughts about driving a car into the shop. So whenever a car's come in the shop and I'm guiding the person onto the rack, I never want to stand in front. I'm going to stand off to the side. I'll try and show you right here. So I'm not in front of the vehicle. I'm off to the side, but I can see where to line up here. If I have to see the other side, I just quickly check and then just move across and then check this side. But I'm not going to spend any time in front of the vehicle unless I get trapped and the vehicle goes forward. So a student driving in has to drive over the rack arms. So they've got to go over the rack there. And that represents some resistance. So if they hit the throttle and go too hard and come in, and you're up in front of the car, you might get squished between those benches. So that would be pretty scary. Hopefully it goes without saying, but nobody can move a car around in this parking lot or this shop without a valid California driver's license. But even if you have a driver's license, a lot of you obviously have not been driving a long time, so you're not super experienced, and we have kind of tight quarters with lots of cars. Always stop and ask myself or a shop aide, Mrs. Tway, to back the car up or pull the car into the rack if you don't feel comfortable doing it. And I'd rather you erred on the side of safety and asked us to do it. When we're driving a car into the rack, especially the red rack, because you can drive off it if you're not careful, we're going to make sure you have somebody up there guiding you and you're paying it real close attention so that we can get you even on the rack and we don't drive off. I have had a student drive off into the middle. It didn't hurt the car, but it was pretty challenging for us to get it out of there. All right, so next what we want to look at is we want to look at a couple other items, and the first one is cooling a radiator. So we just want to talk about a radiator. So here's a radiator here, and we're actually going to pull this one out today, and there's the upper radiator hose. And if I want to cool this engine down so I can work on it, the best thing to do is to take one of these shop industrial fans here and then just lay it right on top of the engine here. And just lay it right on top of the engine with the engine off. And I'll just lay it right down. I'll make sure that I don't lay it across the battery and arc the positive and negative terminal, but just lay it on there, full blast, put that fan on for 2 or 3 minutes, and that engine will be cooled down. It's really nice to do that, maybe more like 3 to 5 minutes. Really nice to do that to get the engine ready when you're going to do an oil change so you don't burn your hands on the oil. If I want to cool the cooling system down, then the best way to do that is to put one of these fans right in front of the car and turn the fan on. Take a garden hose and just run it over the top of the radiator or spray it into the front. This is the air conditioning condenser. But the water will go through and it'll get cooled as the air passes through into the radiator. If you're at a gas station, you've overheated or something, or you're at home and you've overheated and you don't have an industrial fan, what we like to do is spray water into the front of the radiator, run it over the top, and we actually want to have the engine running as long as the coolant level is not too low. The reason why we want the engine running is, as we're cooling the radiator, it's taking the cool coolant into the engine coming out. Turn your heater on full blast, because that gives you an extra little heater core, which is a little radiator and another fan, and that will add some cooling to the system. How do you know if you're too low in coolant? If you turn the heater on full blast and it blows cold when the engine's hot and you've been driving, that's because there's not enough liquid coolant in the cooling system to actually heat up the heater core. In that case, you have no choice but to shut the engine off and then spray water into the front of the radiator or get an industrial fan to cool it down slowly. Okay, next I'm going to pull us back over here to the tool panel, and we'll talk a little bit about fuel filter replacement and opening up the fuel system. So here's a fuel filter that we may want to replace on a car. And one thing to know is that since the early new millennium, California has outlawed fuel filters, external filters. So now all the filters are in the tank, and that's so we don't get leaks of fuel and get hydrocarbons going into the environment. But when we do have to change a filter like this, we're going to take some precautions. We're always going to, when we take the line off, we're opening up a high pressure fuel system. We want to depressurize the fuel system first. The best way to do it is by going over to a vehicle's underhood fuse panel, usually. It's not always the same on every car. And going to that fuse panel and pulling it open and looking on the detail on the underside, if it has it on the underside. And we're looking for a fuel pump fuse, and maybe you see it before I do, seeing if it's real obvious where it is. And it's not real obvious to me where it is. It may be there and I'm just not seeing it. But if not, I'll have to go to Mitchell ProDemand, figure out where it is, and then remove that fuse and then start the car till it dies. And when it dies, that means it ran out of fuel pressure because you killed the pump. And now it's safe to open up the fuel system by unbolting that fuel filter, and you're able to, at that point, safely open it up without gushing high pressure fuel. So when you get ready to change a fuel filter, one of the things we're going to do is we're going to bring a fire extinguisher over by the car. We'll get one of our metal drain pans that are on top of the flammable cabinet. You can see way down there in bay 1 on top of the yellow cabinet down there. We'll grab some rags out of the dirty rag bucket, so we have some rags to sop up any extra fuel, and the pan will catch some fuel. That extra fuel gets tossed into the sawdust barrels and these dark trash cans over here. That one right over there is the sawdust barrel right there, and there's actually another one right over there by that car, and that's where we put our waste, little small quantities of waste fuel. And so you'll have this when you do open up a fuel system, we're going to use a line wrench, or what's called a flare nut wrench, and these grab the line fittings on 4 sides instead of just 2. So these are a lot better than the regular open end wrenches, which only grab it on 2 sides. Believe it or not, you have enough strength, that open end wrench, to come like this, and the flats will actually spread and strip and round off the nut. You can't do that with these. These are way thicker and they grab it on 4 sides. So these are the flare nut wrench or line wrenches. Those are used for brake lines and fuel lines. This morning we're going to continue our discussion on safety equipment, and I know this is edited into another video, but it's a new day for me. So we're going to talk about drills and mini grinders first. So whenever we're using either a corded drill or a battery powered drill like this, or a mini grinder like this, which is pretty versatile tool, we're going to definitely wear safety glasses. We're definitely going to wear a full face shield. The drill bits will tend to throw chips off of the drill bits themselves. The mini grinder will throw chips, but it can also, especially on this thin cutoff wheel for cutting steel, these can break and then the pieces go flying. And horror stories, pictures of them stuck in people's faces. Never here at San Luis High, but it has happened out there in the industry. So just a couple things about drills first. First, the battery operated chuckless drill that you're used to probably from home, where you can hold this and it opens up the chuck, and then reverse the switch right here. So you can see the switch on both sides. That's loosening, that's tightening. It does have a speed adjustment, slow and fast. If we hold the chuck, it locks down on the drill bit. A couple things about drill bits. So a lot of people don't realize this, but there's two cutting edges on a drill bit. There's one there, and there's one. See if it'll focus on it. Come on, focus. Okay, so there's two cutting edges, one right there and one right there. And the flutes here are for cutting oil and chips to be channeled away from whatever you're drilling through. So a couple of safety things. Yeah, you don't want to get your gloves or rags or anything wrapped up in this. So it's usually better to not be wearing gloves to do this. I'm just doing it to keep my hands clean. When we drill, the larger the diameter of the drill bit, the larger the drill bit, the slower we want to spin it. The smaller, the faster we want to go. And this is a variable speed battery operated chuckless drill. When we're doing aluminum, you can use WD-40 as a cutting oil. That works. When we're doing steel, there is a cutting oil, but usually we do it dry. But you can use some cutting oil. It's very important that you spin it in the correct direction. In this case, we're going clockwise if we look at it from this end. Okay, to you, it looks like it's going counterclockwise, but it's actually going clockwise from my vantage point, so that the cutting edges here are the leading edges and they're hitting first. The cutting edge there is the leading edge and it hits first. Trying to get that where you can see it, kind of see it. So the mistakes that most people do is the drill bit's not sharp, and another mistake, well, if it's not sharp, it's not going to drill through what you're drilling. And another mistake is they spin it too fast, or they spin it backwards and they don't know why it doesn't cut. It only cuts in the forward direction. And again, the larger the diameter, the slower. And you can go on Google and it'll show you a chart for, based on the diameter, how fast you should spin it. But just a moderate speed for a drill bit like this, and then for a very small, like a 1/8 drill bit, you're going to go full blast like that, okay? Whenever we're drilling anything, any piece of metal that we have needs to be clamped down. So we'll clamp our work. We're going to drill through this piece of steel. We'll either clamp it down to a bench with a C-clamp, or you might be able to clamp it to something with vice grips, or let me grab my camera, or a lot of times what's even better is that we clamp it down in a vise. So here's your vise right here. And what you'll notice on this vise, which tightens this way and loosens that way, we've got some soft jaws on here, and they're dead soft copper, and they work really nice for keeping you from marring whatever you're drilling. You can take them off and use it with the steel jaws, or you can use them with the dead soft copper jaws. In any case, that vise is great for holding things while you're drilling. One other thing, if I were to take a piece of sheet metal, and we define sheet metal as 1/8 inch or thinner, this one's about 1/4 inch, but just suppose this is a 1/8 inch or 1/16. What we're going to do is we're going to take a piece of wood and put the wood underneath it. We call it backing up with a piece of wood. Then we clamp the two together. So when the drill bit goes through, it tends to bend the metal on the bottom side down, and it wants to grab it and then spin it. And it will do that with sheet metal pretty regularly unless you have a piece of wood underneath. So it's critical. Put it like a piece of plywood underneath, clamp it down, you drill right through, and it'll work fabulous. And you'll go, wow, I wish somebody would have taught me that a long time ago. Just a couple other things on this corded drill. This is a variable speed. I'll lower the camera so you can see a little better. This is a variable speed. It's got a handle here that you can move around, tighten it up, and like this, and it's got a cord. So this has a lot more torque than that battery operated one. There's the switch right there to change direction. Okay, and you can also, this will actually lock the drill so it's on all the time. When I pull the harder I pull it, the faster this goes. One kind of unique safety feature of a drill like this is, or a unique concern, I should say, is that when you put the drill bit in and you tighten the chuck on it, you're going to use a chuck key like this to tighten this guy up. So you put that in, and you're going to spin it and tighten it. Now it's in there really, really tight. You never want to leave this in here because if you pull the trigger, it's going to go flying. So in any case, this corded drill has a lot more torque. So when we're struggling to get through something that's really thick or hard, we're going to use this rather than this. But going through plastic and aluminum and sheet metal, this type of drill does great. Okay. Let's talk a little bit about the mini grinder. We've got three different wheels here. This one is a sandwich of sandpaper, believe it or not, to just clean up the surface of metal, and it does a great job. This one is a abrasive wheel. It's got like a fiberglass mesh with this abrasive compound. We're going to grind on this outer edge there and this outer edge here. This is really great for removing material fast, grinding down welds. This is a cutoff wheel. This is a 1/16 cutoff wheel, and these are fabulous for cutting exhaust off or cutting steel off. They work really fast. All of these are consumable, so they wear away as you use them. Super important to be wearing a face shield when you use this. There's a guard on here to kind of keep the spray from hitting you. You also do not want the spray, particularly when you're using these two wheels, make lots of spray. You don't want that spray to hit a car, either the paint or the windshield. If it hits the windshield, it'll ruin it almost instantly. If you're near a car, we'll take the fire blanket and cover the windows so we don't. And just so you know, the way you change the blades or the stones is we push this button until we roll it around until it locks it, and it's locked right now. And then we switch hands, it'll be a little easier. I'm going to drop the camera so you can see a little better. So we're going to go ahead and do that a little better. There it's locked, and I'm going to put this in. And I'm going to go ahead and loosen it like that, and then unspin it. I'm going to go ahead and put it back on, snug it up. And so again, we're holding this button here, and we're doing this when it's unplugged from power. We do not want it plugged into power. When you're done using the mini grinder or the drills, let them come to a complete stop, set them down so that the stone is facing up. So there's no possibility of it catching and going off and spinning and causing you some heartache by hitting you or something like that. Okay, so that's those drills. So next we're going to look at the bench grinder and wire wheel right here, and I'll do a quick demonstration so you can see what this is used for. But it has an electric 110 volt motor with a common shaft, so when one side spins, the other side spins. It is okay for one person to be working on the wire wheel while one person works on the grinder. Some general safety things first. First, you're always going to have safety glasses on and a full face shield, which I have hanging on the wall right here. So we're going to put our safety glasses on, face shield on. When we use these machines, we've got to take our gloves off, and we can't hold anything with a rag. And the reason for that is that the wire wheel in particular will grab the glove and suck your hands in, or if people take a rag and wrap the metal piece that they're working on with a rag, if they go like this, it'll grab this and suck your hands in. So the reason why people want to use a rag or want to wear gloves is because as you grind or wire wheel, it gets hot. So what we typically do is I have a cup back here that I have water in. So you wire wheel or grind, dip it and cool it, wire wheel, grind, dip it and cool it. So just to show you what it does, let me turn it on. So the wire wheel, yeah, you can't
tell much, but it kind of cleaned up that corner right there. And if I grind on this, you can see the big edge right there that I ground off, and so on. So first, for general safety rules like this, we never use it when it's off and coasting to a stop because it'll tend to grab your work from you. Always work it, use it only at full speed. Again, no gloves, no rags, safety glasses, face shield. Further, no long hair, no dangling jewelry, no loose clothing, any of that, because it can all get sucked in and wrapped up around it. Many families have these at home. They're fabulous tools. This one has these two little extra shields to kind of block you from stuff flying. The wire wheel in particular, it does throw wires. It's normal, so you definitely want that face shield on. And this stone can break apart and throw chunks, so you definitely want that face shield on. When we're using the wire wheel or the grinder, we're always going to stand with a strong stance. I call it a karate stance, where your one leg is behind the other, and so that as you're working, it's not going to knock you over or something like that. Additionally, you're always going to stand to one side of the wheel there or there, never straight in front of it, so it'll tend to throw things at you. Next, on both of these, here's the center point of the wheel. You're always going to work below the center line of the wheel, and I'll bring the camera over and get a better shot of that. So if I bring the camera like this, so you're looking at the wire wheel, here's the center right here. I always want to work from the center down so that the stone's hitting me like this, because if I was up here and the stone hits, or the wire wheel hits this, it's going to tend to throw it at me. This way it tends to pull it away from me, and that's safer. Never hold it against the direction of rotation because it would tend to throw it. Always hold it in the direction of rotation. So if I'm trying to wire wheel this surface and I want to get the other surface, I just turn it around and do that, etc. With the bench grinder here, I'm going to put the camera over here so you can see the bench grinder a little more clearly. So with the bench grinder here, it has a tool rest. And so whatever we're grinding, we want to lay on that tool rest. We're not going to hold it up like into the rotation of the wheel, because again, that would tend to hit it and throw it. If we're going to grind the edge, we're going to lift it like this and let it come in the wheel like that. So the tool rest is no more than an 1/8 inch away from the stone. So what we don't want to have happen is we don't ever want to take sheet metal that could get caught down in here. So we can't grind any sheet metals, and we define sheet metals as an 1/8 inch or thinner. 1/8 inch and above an 1/8 inch, we can grind on this no problem. You don't want to use aluminum or solder or any soft metals. Like somebody's done a little bit of aluminum, you can see the bright spots. It tends to clog the pores. And I can get that out with a sharpener, but when I do, it wears the stone out. And this thing needs to be sharpened right now because it's got a groove in the center and it's got quite a bit of aluminum, so I need to sharpen that up and get that stressed up nicely. So I think I got everything there. So let's continue on. So this machine, this Robinair Cooltech, is our AC recovering and recharging machine. And I'll pull the cover off so you can see it. What I want you to know, I don't know why the camera's not focusing. Come on, dude. Focus. Sorry. The camera is not cooperating for the moment. Let me see why. Okay, there we go. So this Cooltech 34788 is for evacuating and recovering and recharging R134 Freon. Just one thing I want you to know is that nobody can use this machine unless they are federally Section 609 certified. It's a certification that's easy to get on the web. It takes about 45 minutes, costs $25. And the federal government just wants to make sure that when you recover, recharge AC Freon, that you know how to do it safely so that it doesn't pollute the environment. Chlorofluorocarbons are known to cause troubles for the ozone. So you can't do any repairs on an AC system on a car or use this machine unless you're Section 609 certified. And it's mostly for the environment. The only safety concerns is that if we release Freon we could spray it with the dye into our eyes. So obviously we're going to wear safety glasses. One time I was doing a demonstration with a class and I was taking a fitting off, and the top fitting was supposed to come off and had a check valve in it. I didn't realize that the top and the lower were spinning together. So when I took it off, it just instantly just blew 2 pounds of Freon all over me and the students, and we had green dye all over us. It was a bad day. But we had safety glasses on, so we were safe that way. Just to show you this machine, we do have it, and students can get Section 609 certified. Again, it takes about half hour, 45 minutes, $25 online, and it's a good feather in your cap or on your resume when you go to look for an automotive position. You already are Section 609 certified for AC recovering refrigerant. Let's continue. All right, we're going to talk for just a couple of minutes about our tire machine. It's not something in our beginning classes that I necessarily use, but in our advanced classes we definitely use. It has a number of clamping parts like this. That's for breaking the bead, and obviously getting your fingers stuck down in there or your foot stuck down in there would be bad. We put the tire up on here like this and we clamp those out like that, etc. And having our fingers underneath would get it caught. This guy goes up or down. Sorry, let me position the camera a little better. This guy's for breaking the bead, and we're changing the TPMS sensor. We go up like this, so we wouldn't want to get our fingers caught underneath there. But the most dangerous thing is airing up the tire, and we have this nozzle here. I'm going to move the camera over here where you can see a little better. Because we don't normally use this in this class, I do allow you to use it, allow you to change tires with my help. So here's the air hose, and it usually just hangs here, and you can see the gauge, you can tell how much pressure. And it says right here that when you're seating the bead, you're never supposed to go over 40 psi. It says it's here as well. So when we are putting the tire back on the rim and we're adding air, we never want to go over 40 psi to get the beads to pop, because they can pop the bead off and it'd be hazardous to it hitting you in the face, like you see here and here and here. The way you do the air is you push this pedal here, and okay, and so that's how we get air into the tire with this nozzle right here. But in any case, we're never going to exceed 40 psi. We're going to just watch our fingers so we don't get anything pinched. And that's the only thing I wanted to talk to you about on that. And the last couple of things I want to do are just some general safety rules. And I'm going to grab a fire extinguisher, which I have on the wall. And when you walk into a shop like this, one of the things you want to do is you want to notice, where's the safety equipment? Well, guess what? There's a fire extinguisher over on that wall by that personnel door. There's a fire blanket there. And then by the office door, that little red bracket to the left of the door is where this fire extinguisher was just hanging. And there's a yellow ventilation system over there, and there's a yellow ventilation system here. This one turns on with that box right next to the fire extinguisher. This one over here turns off on the top of that power panel over there. There's a switch to turn on the room ventilation. So we have a room ventilation. Actually, we have two room ventilations, okay? Something about fire extinguishers that in the previous part one of safety I didn't get, and that is that, number one, when you buy one of these, try and buy one with a metal fitting up here. If it's plastic, it can't be recharged and you have to replace it, and these are about $40. If it's metal, it can be recharged for $15 or $20. They last for about 2 years, and then the pressure goes out of them and they'll read on the gauge that they're no longer charged. This one's still in the green, so it's good. I want to highly recommend that you, as a result of this safety instruction, you want to ask your parents if and where they have a fire extinguisher in their home. Hopefully in or near the kitchen, because the kitchen is the greatest source of fire, also the garage. If you get a grease fire in the kitchen, you can extinguish it with a chemical fire extinguisher like this. You never put water on it, because the water hits the hot grease and vaporizes so rapidly it just blows the grease out and spreads the fire and potentially burns you. So we can use a fire extinguisher to put it. We can take a lid to a pan and just smother it like that. That's a good way to do it. We can throw flour on it and douse it like that. But in any case, we do not ever put water on it, because it'll cause the grease to blow out of there because of rapid vaporization. It's very important you know where fire extinguisher is in your home. It's very important the smoke alarms in your home that they're in place and that the batteries are no more than 1 year old. The 9-volt batteries in there go bad after about 1.25 years. So I mark my calendar, and every June I go through and change the batteries. And when I change the batteries, I take my voltmeter and check the voltage, because if they're not up at 9 volts, they're not going to work right. When they get down to around 7.5, 8 volts, which they do over time, then what's going to happen is you're going to have a chirping smoke alarm at night, get woken up and be grumpy and that kind of stuff. Okay. Highly recommend you get one of these for your car. This size, not the kitchen size. This is the $40 size at Home Depot or Miners or wherever else you get it. Again, buy one with the metal head. Please, please have one in your car that's fully charged. Over the years of driving, I've come up on 3 car fires and 1 brush fire. You don't ever want to come up in a car where somebody's burning and you can't, or going to be burned, and you can't do anything about it. I had a student come upon a head-on collision. The guy in one of the cars was trapped because the dash had collapsed on his legs. The car caught on fire, but it was a long ways away because the engine is always at the opposite end of the car than the fuel tank. So yes, that's right. Old air-cooled Volkswagens, Porsches, and Corvairs have the engine in the rear of the car, the gas tank's up at the front. There was a head-on collision. That guy was trapped. My student and other people were taking water bottles and trying to extinguish the fire because nobody had an extinguisher. The gentleman was severely burned, airlifted to Fresno. The burn center, died 2 days later. And my student told me, Mr. L, he said, if I had had a fire extinguisher, I would have saved his life. And he went out, got one the next day. I went out, I had one in one of my cars, but my other 2 cars, I went out and got them, and now all 3 cars have fire extinguishers, and they're always kept fully charged. Super, super important. One last thing, we were talking about electrical panels earlier, at least one thing I forgot. And it's really important you know where that panel is, and I think I said that it's important that you know where the panel is. So I think around your home, knowing that the smoke alarms are in place and that the batteries are fresh, knowing that you have a fire extinguisher, you know where it is, knowing that where the electrical panel is so you can turn off electricity in the event of emergency. But one other thing, and that is the gas meter, to know where it is and know where the little shutoff valve is on that gas meter. It'll have a pipe, it'll have a small little valve. When it's 90 degrees to it, it's off. When it's in line with it, it's on. Home Depot sells a wrench, and Miners does too, for like $3. And I have zip tied my wrench to the pipe. It's a galvanized steel, so it can be out in the rain. I've zip tied it to the pipe with enough zip ties that I can get it onto the valve and turn off. If there's an earthquake and you have a gas leak, you're not going to be able to go and find the wrench probably when you need to. So put the wrench, zip tie it to the valve, and so everybody in my house knows that there's a valve there, there's a wrench there, and they just have to turn it 90 degrees and the gas is off. So that's some good home safety tips. A couple other things. General safety: long hair, loose clothing, dangling jewelry, watches, rings, all we got to either take off or contain in the cap or put in a hair tie or roll up your sleeves or take your jewelry off, because we don't want anything that can get wrapped up in anything revolving that'll suck you in or pull your hair or any of those kinds of things. We're always wearing safety glasses 100% of the time. Whenever we lift something, we're going to lift, and I'll just put this down, we're going to lift with our legs like this, keeping our back straight. Super important. I hurt my back lifting an engine when I was 22. Super stupid. Get a friend, get a buddy. If it's too heavy for you or both or 2 people, then get an engine hoist. I wish I had. I spent a decade after that going to chiropractors and spending money and trying to get my back under control. So really important to take care of yourself. Okay. All right. That's everything for this part 3. Thanks for enduring all the boring stuff. Hopefully you got something out of it.